Yes, good afternoon, engineers. I want to welcome everyone in this MEP Expert last session for today. I hope everyone who have joined this training is ready to start with the training. So, while we are waiting for others will continue with where we will be. And it's my pleasure to welcome Mr. Engineer Tejesh and start with sharing his screen and training at the same time. Mr. Tejesh, are you okay?
I am doing well. I'm doing well. Back home, doing well. Can you guys
Nice
hear me properly?
Yes.
Awesome. Yeah, same
Nice to
here.
see you once again.
Same here.
So, can you kick off with the training, please?
Yes, I will. So let me share my screen. All right. So hope everyone is doing well and okay. There were few doubts that came in during the session in person. I wanted to make sure that we address all of those doubts and then we move further and take over any more doubts that we might have. So now since everyone is online, I assume no one is in a classroom. Excuse me. If you have any questions, please feel free to put it in the chat box and then we can have a discussion regarding it. So let's move ahead with the questions that we had gotten on the chat box on Friday. The first one was regarding the different types of lighting that need to be used. Speaking about the task emergency lighting, the energy efficiency lighting. So dear friends, as we had spoken about the lighting the other day from the presentation, the goal of the lighting that is used in a given hospital setting is to provide adequate foot candles or the lux levels, right? We had checked that we needed we needed like 50 foot candles in, let's say, a patient room, while on the other hand the operating rooms required somewhere around like 80 foot candles. And again, 1 foot candle approximately equals to 10 lux, right? So we are looking at 800 lux required in the hospitals, while in the patient room we are looking at around like 500 lux, right? So now, as I mentioned the other day, the lighting systems specifically that are used in hospitals have gradually progressed from, let's say, incandescent to CFL, the compact fluorescent lamps, and then now progress towards LEDs, where they have become as energy efficient as possible. So accordingly, the LED light fixtures are available throughout the world these days for making sure that we have the most energy efficient lighting given on a project. I would recommend focusing on the LED lights for specifying for your projects. Again, as I mentioned the other day, let me also do one thing and share a whiteboard. So I'm sharing the whiteboard now. If someone can just put it in the chat box and let me know if you are able to view my the whiteboard that we are talking about. So the other day we spoke about, awesome, thank you so much, Gorky. We spoke about the equation for calculating the foot candles, right? We had spoken that the foot candle, when it comes to lighting, is nothing but lumen upon the area in square footage. All right, so this is in square foot. In case you require the number in lux, the formula will be the lumen divided by the area in square meter. All right. Please note that there is one more component in this given equation that comes into picture. That is regarding the efficiency, the efficiency of the light fixtures. It is many a times also called as efficacy. So what that means is when you have a brand new light fixtures, you can expect the output out of them to be the highest. And when we talk about output, we are talking about the lumen, right? So when you have brand new light fixtures, your lumen output, if let's say the manufacturer provided lumen output is 1000 lumen, then you can expect close to around like 1000 lumen, maybe somewhere like close by 995, something like that. But it's very high initially. But as the life of the light fixture progresses from brand new to the end of the life of that light fixtures, what eventually ends up happening is that the lumen output from the given light fixtures starts reducing gradually. Again, you might see dust accumulating that contributes to the loss in the lumen output. You might also notice some yellowish tint happening based on the material of the light fixture. That will also start reducing the light output, the lumen output of a given light fixture. That is where we will say an efficiency number will come into picture. All right. So let's say if you have a given parking lot, right? So you have a parking lot is open to, let's say, the outdoor conditions. So what happens is the parking lot efficiency factor will be a bit low. So somewhere around like 0.8 we can consider for a parking lot. While if you have, let's say, a given office, which is an interior where the chances of, let's say, the weather factors affecting the light fixture, or let's say the dust factors affecting the light fixtures, or even some of the vandalism happening to the light fixtures is not that much in a given office space, that is where we would say that the efficiency factor is somewhere around like 0.9, right? So that is what this efficiency factor will come into picture. All right. So let's say if we have in a given space 1000 lumen of light fixture, and the area of that space is 100 square foot, and let's say if it is a given indoor setting that we are talking about, so we are talking about the foot candles for this particular equation to be somewhere around 0.9, right? So 10 into 0.9, sorry, 9. 10 into 0.9, that will give us a 9-foot candle number for the given office. If it was a parking lot, then of course you would have to reduce the given efficiency for the light fixtures. Now, going back to our project over here that we had left, when we talk about, let's say, a patient room, we need to properly adjust the light fixtures to achieve a foot candle level of minimum 50. If it goes high, that is fine, but make sure you try to be around 50-foot candle. What ends up happening is, let me share my Revit screen now. What ends up happening is if you have too high of a lumen output out of the light fixture, that contributes to an increased foot candle level. The brightness starts creating issues with the visibility of the patient, right? So if you have very bright lights that you have in a small space, it will usually trickle headaches, nausea. So try to keep it to what is recommended. And you can also refer to a standard called as IES foot candle level standards that we are talking about over here. So the foot candle levels in a given space is recommended by the Illumination Engineering Society, and they have done these calculations based on empirical results, and accordingly they have gotten these recommendations. So you can simply try to find IES foot candle level, FC level, and you'll get these recommendations. Again, dear friends, just like the ASHRAE 62.1, 170, ASHRAE 90.1 that we dived into last week, this is a standard. It's not a building code. But what ends up happening is many of the cities, the municipalities, the governments end up adopting these standards as codes. So make sure if you are working in a particular geography, you have understanding of which building codes to be used or which standards that is given by the government to follow that needs to be used. All right. So over here, as you see, there are different types of spaces, right? So let's say you have a manufacturing facility for airplane where the primary application will be drilling, riveting, screw fastening. You're looking at somewhere around like 75 foot candle. In the case of, let's say we have a patient room. I'm not sure if there is a patient room. Let's check about hospitals. So we are talking about hospitals, operating rooms, somewhere around 100 to 200 foot candles is what is recommended by IES. Well, I had told you regarding 50 foot candles. Please make sure what is recommended by your building code. I think so what I have is based on the building code that was in the state of California, but this is what you can have it for a given operating room. 80 was what I spoke about. All right, so this is the given standards that you can use for a given space. Now this will of course entail not just the hospitals. If you are working on a hotels project like lodging or something, you can also use these values. All right, so now when we are talking about the formula for all of the lumen package in this given room and then dividing that by the square footage of the given room and then multiplying it with the efficiency factor, we are getting the foot candles. But dear friends, please note, last time when we had done the exercise for the surgery room and we were trying to achieve somewhere around like 80 foot candles in this given surgery room, if you follow the IES-NA around 100 to 200 foot candles, what we had done, we had used 4 of the luminaire. Now from the past given week, what we had discussed was that for a surgery room, we need to have a UPS that will be our primary backup source when there is power failure in case of emergency power system. And then the secondary will be the DG set, the diesel generator. All of the light fixtures, even if there is a power failure in the given surgery room, need to be on. All right, but that is not the case when we talk about, let's say, the corridors. The corridors need not all of the light fixtures be on the UPS power. They can be on the DG set, but there is also a concept called as path of egress, PATHOFEGRESS, path of egress. What that means basically is, in case there is a power failure, there is a given path for the occupants to exit out of the building from the fire exit. So in this case, the path of exit, let's say for this patient room, will go all the way from this point to this point, the nearest exit. All right, and what the building codes will usually ask us to do, the building codes will ask us to make sure that the minimum foot candle is supplied when there is a power failure. In case the occupants of the room want to exit from the room, we want a certain given minimum foot candle level or lux level. Again, this is dependent on the building code of a given country or a given geographical area. So always make sure that you have that properly modeled. Now, what we are going to do is, we are going to do a simple exercise. First, what we'll do is, we'll check what is the area of this particular given corridor. All right. What we can do is, the other day I did mention regarding the tool that we use for hatch patterns, something similar to what we have in AutoCAD. It is called as filled region. So I assume everyone has their Revit open. So with the Revit open, what I want you to do is go ahead and click on the annotate ribbon. Once you click on the annotate ribbon, in the details section over here, you will have the region. You'll have two types of region. One is the filled region and the other one is the masking region. What we need to select is a filled region. We just need to trace out this particular corridor and try to check the given square footage. Why are we using square footage? Because we need to understand what is the given area for us to calculate the minimum foot candle levels that is required. Okay, not average, the minimum. All right. So again, going to the annotate ribbon over here, we will select the filled region option in the details section over here. So go ahead and click on filled region, and then what that will do is that will open up another ribbon for us, the modify ribbon, where it is asking us to start tracing the boundary of the given filled region. All right. So what we'll do is let's start from the upper top over here, and then we will start drawing the filled region over here. Please make sure we are using only the area of the corridor. We don't need to go anything beyond the corridor. So make sure we draw an even polygon so that the first point and the last point of a given polygon meet. Unless and until it does not meet, or if it overlaps as well, Revit will not identify it. Right now I have created this polygon with the option of modify in the filled region. I will explain it again one more time. I will go from first. First, we need to go to the annotate ribbon on top over here. Then we'll go to the filled region over here. And then once we click on that filled region, this particular window will show up. Make sure line is selected over here in the draw section, and then start drawing the polygon that will include all of the given corridor. So if there is an inch left here or there, that is fine, but try to make sure you draw the polygon throughout the given room properly. And again, when you are closing the polygon, make sure the starting point and the ending point match. If you try to do a rectangular thing, if Revit does not identify, you see this is an open area of that polygon. So make sure you go ahead and properly close it. So hence basically saying that try to make sure that you have identified your starting point. Once this is done, go ahead and click on finish edit mode. What this will do is it will create a given polygon for you in a filled region. So any questions till now? Any questions till now? All right, so since there are no questions, I'll take that as a no. If anyone has any questions, please drop it in the chat box and we'll take care of it. Now, this is the filled region that we have created over here. Okay, don't worry about the solid blank. We are going to delete the filled region in a moment. What we need to do is we just need to identify how much area is covered in the given filled region. So in this case, when I click on the filled region in the properties menu over here, we see that the area under the dimensions is 2751.30 square foot. Again, I have not taken each and every corner of the corridor, but if I try to click on the control point over here, just like your section view, you have a control point for your every face of your polygon for the filled region you have drawn. If you click, hold, drag, you will see that the given polygon is moving as per your requirement. All right. So make sure you have as best possible outline of your given corridor drawn, and that will basically give you your square footage. All right. Now, what we need to do is, for in case of emergency, right? If there is an emergency and someone wants to exit from here to the nearest outdoor, nearest fire exit, basically if there is a fire and then the person needs to run out, so they will check for the nearest fire exit. In this case, what we will assume that this is a fire exit so that they can go out from this end. So what we need to do is we need to properly analyze how much foot candle, how many light fixtures we need to place in emergency mode, that will make sure that minimum foot candles are maintained. Now, I've been talking about minimum foot candles again and again instead of average foot candles. That is because only particular light fixtures will be on when there is a power failure. Okay, and again, we are just talking about the spaces where you have like an exit path of way. All right, so again, this corridor is 2754.43 square foot. Now we have gotten the area. All right, so area was in the denominator. On the top, it was the lumen. The division of both of these numbers was multiplied by the efficiency factor, and it was giving us the foot candle. Now what I'll do is I will go ahead and share my whiteboard again. All right, so over here I am opening my whiteboard. Again, we are using the same formula that is over here. What we have seen is that our area is 2754. Since it is an interior area, we can take the efficiency factor of 0.9, and then we need to have a foot candle level. Okay, so what we are going to assume for this case, we will assume the foot candle, the minimum foot candle that we require will be 1 foot candle in emergency mode. All right, so when there is a power failure, we need to have at least 1 foot candle. All right, so that is approximately around 10 lux that we talk about. Okay, that is just enough to make sure that in case of emergency, the path of egress, the way from where we need to exit the given space is maintained. Okay, so now based on this, what we can get is the given lumen, correct? Because lumen is the one that is on top over here. All right, so let's calculate the lumens, how much lumen we require for this given space, 2754, and then divided by, oops, 54 divided by 0.9. Okay, so as per my calculation, the lumen value that I got was 3061. Oops, Grace, your mouse. Okay, thanks. 3060 lumens is what we require. All right, now what we need to do is, now we'll go back to our Revit model. It is fine that if you want to delete your given filled region, since the only purpose for it was checking the area. Now what we need to do is we need to identify the light fixtures we are using, and on that day we were using the majority of the light fixtures as 2x4 120, right? So this is one of those light fixtures, and then we will check how much lumen is given out by this particular light fixture. So as we see, the light fixture is rated for 96 watts and we have 89 lumens per watt. All right, so if we multiply 96 into 89.06, we see that we have somewhere about 8549.6 lumen that we will be getting. All right, so now what we will do is we'll start placing the light fixtures based on the given path of egress like this. All right, from this point, we will have the light fixtures going this way, and from this point, the last point, we'll keep it going on this way, since this seems to be the closest possible path of egress. All right, so let's go ahead and take this one. We'll create similar, and again, please note that we will place it on work plane, the same work plane that we were working on, first floor ceiling. We'll make sure we start laying out the light fixtures. Again, space will mean that you can rotate the light fixtures 90 degree, and on the other side as well, we'll start placing it. All right, dear friends, I know that this might not be similar. As you see, from one point to other point, this is around 17 feet 6 inches, this is 13 feet 7 inches, this is 16 feet 6 inches or something like that. But what ends up happening is these trophers are usually used in a given T-bar ceiling or a grid ceiling.
Hello,
right?
Excuse me, sir.
Yes.
We are still seeing the whiteboard.
Oops. So sorry. Okay. I will stop sharing over here and I will share my screen again. All right. So what I will do is, can someone confirm that they are seeing my screen now?
Yes.
Yes.
Thank you so much. Sorry about that. Okay. I have undid everything. So I was talking about the light fixtures over here. That day we had placed the light fixtures to match the lux level or foot candle level. We had used a 120 volt light fixtures, a 2x4 that we need to place in different types of rooms. So now what we are trying to do is, we are trying to check the path of egress, right? So the path of egress, if I draw a line, the detail line that we checked the other day, what it will look like is something like this. It will start from this point. This is a corridor. If someone has to exit from the last point, this is the path of egress that they will take from this point. All right. And then for this point or this point, the path of egress will look something like this. The closest possible exit will be over here, right? So we need to consider a person is in danger and then they are trying to exit the given space. What is the easiest possible path it will take? All right, the person will take. Again, this is something that again goes back to the building codes. Usually the architect's plans will have the path of egress properly marked, and our given light fixtures need to be mounted properly so that this path of egress is maintained at the given 1 foot candle. All right, so what we will do now is we will start placing the light fixtures along this particular path of egress so that if a person needs to exit, they will have proper illumination done. All right, so now what we'll do is right click. We can do a create similar, and again placement, make sure we have work plane based, then make sure we select the correct reference plane, the same reference plane that we created last week, first floor ceiling, and then we will start placing it along this path of egress. I will delete the rest of the light fixtures that I had downloaded for explanation so that it's not creating any confusion. Now over here, I will create similar. Again, hitting spacebar will rotate the light fixtures in 180 degree. And the last point that I was making before I noticed that my screen was not visible on Revit. The thing is, we will place these light fixtures in ceiling grids, like ceiling tiles or a T-bar ceiling. Last week we checked the T-bar ceiling will look something like the ceiling grid over here, right? So the light fixtures, the trophers that we are placing right now is something like this. The ceiling grid will come in from the architect's model, okay? But as we know, in real world, we might not be getting the latest architectural model right away. That's why we had created the work plane, the reference work plane of first floor ceiling. And that is why we are placing the light fixtures based on that. But again, in a given project where the architect has updated this, these ceiling tiles tend to be 2 feet by 2 feet or 2 feet by 4 feet wide, and our light fixtures are also 2 feet by 4 feet, so they properly fit in the gap that there will be. All right, so now this is how the lighting will proceed for the corridor. All right, now in case of emergency, only certain light fixtures need to be on. All right, so in that case, what we'll do is we'll create smaller chunks of the corridor. We got to know the bigger chunk of the corridor. Now we'll create smaller chunk of the corridor. So again, going to the filled region in the annotate ribbon. Just a minute. Annotate ribbon, you have the filled region, and let's try to draw the area just for this particular corridor. All right, so in this particular corridor, what we will consider is we have 3 light fixtures over here. Okay, 1, 2, and 3. The corridor area is 378. All right, so we need to have 1 foot candle minimum that we need to have in the corridor. All right, we saw that the lumen package of the given light fixture is somewhere around like 8549, which is of course a lot more than we need. So even having 1 light fixture is going to meet the 1 foot candle. We'll do the calculation now for it, just for making sure we have the area right. 378 square foot. Let me now go back to the whiteboard. Let's create a new whiteboard. Okay. So can someone please let me know that they can see my light fixtures, the board, whiteboard?
Yeah, we are seeing your board, but there is a question from online asked by Tony Makumbi.
Okay. Yeah, let me read it out. So Tony's question is, how do we determine the spacing between the lights and the number of light fixtures? So Tony, as I mentioned, the spacing between the lights will be dependent on the given grids that are available. So it is a joint collaboration between the electrical engineer or the lighting designer along with the architect to properly equally space it, right? So if we go back to let me share my entire screen again. So if I go back to the snippet that I had over here, as you see, they have repeated a pattern, right? So they have repeated the pattern to make sure that the lighting fixture fits in one of the grids, right? So after this one, if you count 2 tiles, there will be another light fixture over there. So trying to keep it properly aesthetically pleasing will be one of the biggest thing, but making sure that that path that you are choosing for the path of egress, you have the light fixtures on that path of egress or close by the path of egress. So in case the path of egress is going, let's say somewhere from here on this 3rd tile on my screen over here, then it would be better to have the light fixtures on the other side, all right, on one tile to the left. So that is how you will determine the given spacing and given layout of the light fixtures. Now, talking about the second question that you had, Tony, regarding the number of light fixtures. Now, again, the formula, we'll go back to the formula. I'll share my screen again. I'll share my whiteboard again. Oops. Okay, so I'm sharing my whiteboard again. Can someone give me can give me a confirmation that you can see my screen?
Yes, we are seeing it.
Okay, all right. So Tony, as I mentioned, this is the fundamental formula, right? we are trying to, let's say, maintain 1 foot candle minimum in the given area for the emergency path of egress. In case, now in this case that we had done the calculation, let's say we had, this is another assumption, we had 100 to 1000 lumen coming out of the light fixture, and the area of the room was 100 square foot, and again we had 0.9 as our efficiency factor, then we are meeting that minimum 1 foot candle. Let's say we are getting somewhere like 0.5 foot candle. What do we do then? Then we increase the number of light fixtures, right? The emergency light fixtures. How do we do that? How it will change over here? We simply multiply the number of light fixtures on the numerator. All right, so basically we are trying to increase the lumen, right? So if one light fixture is giving us 1000 lumens, then 2 light fixtures in that same given area of 100 square foot will give us a total of 2000 lumens. All right, so in that case the lumen values will increase, and since this is a product, we will have the foot candle values also increasing. All right, now going back to the average foot candles, till now we have spoken about the emergency or minimum foot candles, but when you have average foot candles, the same concept applies, but all of the light fixtures over here, let's say if you have 3 light fixtures and you have determined only 2 light fixtures are required to meet the criteria of, let's say, 1 foot candle, then you will require only 2 given what do you say, 2 given light fixtures to be on emergency. The third one you can keep it on utility power or raw power, that is fine. But now we are talking about the minimum foot candle of 1. Now if we are talking about the average foot candle for this entire room, what we need the average foot candle, then in that case, if it is determined that we require all of the 3 light fixtures, so on a given floor plan you'll have 3 light fixtures shown, and 2 out of those 3 light fixtures will be on emergency mode. What that means is, in case there is a power failure, there will be a battery backup installed in it or somewhere else, and then that will be powering the light fixtures. All right, at least till the time the DG set kicks on, the diesel generator set kicks on, and then diesel generator set will take care of turning on the third light fixture as well. Tony, did that make sense to you? If you can, please let me know. Okay, there is a good point from Emmanuel. He mentioned, okay, this is fine and good over here that we have let me change my color as well. We have this number, this formula for a given light fixture. If we want to increase it, do we increase it over here, or do we increase in the lumen package as well? Because if you have worked in the real world, you will see for a given manufacturer's catalog, there will be different there will be different lumen out. Now, of course, that lumen output will correspond with the wattage as well. Just like we had something like 96 watts at 86 lumen per watt, something like that in a given in our given light fixture, sorry, Revit model. So just like that, we can increase the lumen output. In that case, what will happen is the wattage will increase. All right, so yes, you have 2 options. You can either increase the number of light fixtures, or in case that is not meeting your criteria, then you can also think about increasing the lumen package, right? So that is how you'll try to make an even distribution for the light fixtures. Emmanuel, I think so. I understood your your suggestion correctly, and he did mention. How about the challenge of making this economical? Of course, the less quantity you have, most of the times the ordering will be cheaper. Your man hours for connecting those light fixtures will be reduced, but we also need to make sure that increasing the lumen package is not affecting the cost. So it is a fine balance between making sure we meet the code as well as we supply the given recommended foot candles. So that was what Emmanuel was saying. So now I hope everyone is with me. Tony, if you can please type the text, and Emmanuel as well, if this answers your question. But moving forward over here, regarding the calculation that we had for our given area. So we had a total of 3 luminaire. We had calculated the lumen package at a total of 8549 lumens. The area was somewhere around 378, right? And then we are applying an efficiency factor of 0.9 since we are working in the indoors. So now 3 into 8549 divided by 376 into the efficiency factor of 0.9 is given us somewhere around 61 foot candle, which makes sure that we are above the 1 foot candle. So now going back to our Revit model, now let me share my screen for the Revit model. Now in this area that we are talking about, can someone confirm that they can see my screen?
Yes, we see it.
All right, perfect. So now in this case that we are seeing for this particular area of the corridor, just having one light fixture on will suffice in the emergency mode. So what we can do is, just like the other day, we had tagged this with, I think so, tag type mark A, right? We had type mark A. What we can do is, since the light fixture is not changing in model number except for the emergency battery pack, what we'll do is we'll duplicate this particular light fixture. So for doing that, make sure you select the light fixture, you go to edit type, and in here edit type, you duplicate it. Make sure you have a unique number assigned to it or a unique name assigned to it. If you have the same name again and again, it will not take it. Revit will say that the name already exists. So what I'm doing is I'm keeping the 2x4 same, dash same, 120 same. I'm just adding dash EM. EM will signify this is an emergency light fixture. So I'll hit OK over here. Now as you see, over here when I had the 120 2x4 120, I had all of this information filled out over here. But as soon as I duplicated it, the information that we had entered went away. So that is why we'll need to make sure that we enter the information again for the new light fixtures. So over here it's the same thing, and over here what we are going to do is we are going to type A-EM. So A is the type of light fixtures and EM is the tag associated with the given emergency light fixtures. What we'll do is start tagging it. There is a question visible already. No, there is no question. So same like the other day where we were tagging the light fixtures from the annotate ribbon I had taught you. So simply hover over it, it will give you the tag. Simply hover over it, it will give you a tag. Now what we are trying to do over here is identify the light fixtures which are emergency, right? Because when you order it, when the contractor will order it, they will look at the tag and then they will understand what needs to be done and how much quantity needs to be ordered. All right. So for that reason, we need to make sure that we have the proper tags. Now, in a given tag, there are different types of tag. There is a light fixture tag. We spoke about the room tags. We spoke about the equipment. We spoke about the power circuiting tag. Similarly, this is the light fixture tag that we had seen the other day. Now over here, you can either keep it with a box, or Revit will also give you an option making it a standard. But when you make it standard, it's just floating with a leader. So it is our responsibility to take it close to the light fixture. Make sure when you're doing this, when you're setting up the standards for your company in Revit, make sure all of these are shown on the cover sheet or the first sheet where you have the symbols and legends and all of the details that are required as a standard for your company. All right. What we'll do is we'll remove the leader line from here, and that will basically give us the light fixture tags over here. So now this is how we will check what is the given emergency number of light fixtures that are required. So just like we had taken the cut for this area of the corridor, what we can do is we can have another cut over here that will take care of this part of the corridor. All right. So now one more point to note over here is for this given area, if we still get the option of we are fine with just one light fixtures at emergency, make sure there are no blind spots. What does blind spot mean? Let's say in that given area that we had mentioned, we again calculate the light fixture to be just one for the emergency light fixture purposes. And then since you see we had not considered this light fixture in this area and you go ahead and use this as emergency, what is going to happen is the path of egress at this point will most probably be downlit. All right, there will not be enough light on this area. So it would be better to have maybe this or this particular light fixtures on emergency, so that if a person is trying to exit from here, they will have this light fixture that will have the foot candle levels adequately in this part, and then when they come on this side, maybe this or this light fixture will illuminate this path accordingly. So make sure you have a good judgment call and making sure that there is no dark spot or there is no blind spot for the path of egress. Okay, there is one question from Fred asking, is there any way that you can set the light as standard and it is applied on the same type of light instead of changing each and every light tag? So yes, now let's say Fred, this is a light fixture, this is also a light fixture. So now once we identify whichever one is emergency, all we need to do is click on that light fixture. In this case, let's say this is the emergency light fixture, drop it down and change it to a 2x4 120 EM. Now next time I tag it, what is going to happen is it automatically will take the EM. You don't have to do it every time. All right, so it is just one time thing, and make sure next time, let's say this is also the emergency light fixture, just make sure it is set to EM, and then when you tag it, it will again give you as A-EM. Hope that answers your question, Fred. So this was the point for emergency light fixtures. Any questions or points till now that you didn't understand? Because the question was regarding the ambient, task, emergency and energy efficiency lighting. So we have gone over all of these points. Any points before I move on to the next one, which was the cable management?
Yeah, there is a question from Fred Rukundo. You can check it and answer.
Yes. I've already answered it, Fred, regarding the tags. We need to just make sure the emergency light fixtures that we have are properly set to the correct type of light fixtures. And if you have that EM tag assigned to it, then it will be assigned with that particular EM tag as well.
I'm sorry.
Yes, Fred.
Maybe the answer that you gave me does not maybe matching what I was asking.
Okay.
I was asking, don't you see this tag's name that you are marking as AEM?
Yes.
Like you are moving it.
Right.
Is there any way that you can move one and then it applies to all lights?
Okay. Revit does not have that functionality yet of moving it. You can tag all of them. So what we are going to do is we will go to annotate ribbon over here. Tag by category is there, and then there is tag all, right? In the tag all, if you click it, it will open this particular window for you. Tag all not tagged. So whatever is not tagged over here, that will be tagged. All right. So now we scroll down. In the light fixture tag, we just identify which one we need. Do we need a standard one or what we need? So we'll go with a standard one. we don't require a leader, the line that we see over there, and then click on the fixture tag. And once you click on apply, all of the light fixture tags will show up where they are not assigned, but we will need to do the background housekeeping work of moving it to the location. So you can, once it is tagged, let's say in the center, you can select it and drag and drop. And that is how you can tag multiple ones at a given time. But please make sure you exercise some caution when doing this. Since we have manageable light fixtures, it is fine. But let's say you have hundreds of light fixtures and you're doing this for the entire project, then there might be some issues where the tags might not be properly assigned the way you want it to be assigned. Does that answer your question, Fred?
Yes, I've been.
All right, perfect. Okay. Any other questions before we move on to the cable management, basically called the conductor sizing? Okay. All right. So now let's move on to the conductor sizing. The other day we spoke about the panel board sizing. Excuse me. For a given space, we had a 100 amp panel that we were assigning to the given surgery room, be it the emergency or be it on the UPS. Now, the usual flow of power. Now I will share my whiteboard with everyone again. All right. So we will talk about the usual flow of power. We will draw a single line diagram. I want to speak on single line diagram as well, so we'll come to it in a moment. But we will begin with the, oops, let me draw it better. So we'll begin with the ground floor over here, let's say, and then let's say we have, oops, and let's say we have a second floor over here, right? So when you have the when you have a building, first point of connection to the building electrically will be from the utility from the given transformer. So it will come in underground or overground, whatever be the case, and then that transformer will step down the current, let's say to 220 volt or 230 volt, whatever is applicable, and then it will go to a given switchboard. Let's say this is that switchboard. I will reduce the size of it. Excuse me. And then we will have the switchboard then feeding the panel boards or distribution panels, or whatever we call it. So now these are the panel boards, right? So in this case, if we have this panel board, then let's say this is the panel board that works on the utility. And in addition to that, we will also have the panel boards that will, let's say, work on the, oops, that will work on, let's say, the UPS power. So it will go to a UPS first, and then it will be fed to the panel board. So when we are doing that, we need to make sure that these wires that we are talking about over here, they are properly sized. So what do we do in that case? Now in that case, what we are going to do is again follow a set of standards. In this case, what you are going to follow, just like on the HVAC part, we had ASHRAE standards that we followed. On the electrical part, we have the National Fire Protection Association's standards that we'll follow. NFPA it is called. All right. So now I'm going to stop sharing my whiteboard and I'm going to share my screen again. All right. So I'm sharing my screen with everyone. Can someone give me a confirmation that we have the visual? Okay, maybe I'll take that as a yes. So, okay, so this is the website for National Fire Protection Association, nfpa.org. This particular one is a rich, abundant source of a lot many types of codes related to fire, life safety, and even electrical. So in this website, we have different tabs over here. If you click on the for professional tabs and then you select the list of codes and standards, what you will come to is this particular web page. If you scroll down over here, you will see all the different types of code sections over here. All right, so they have code section as per the nomenclature, the numbering. So you'll have all the way from 1, I think so, all the way up to 112 or 111. So what we need to do is we need to find the national electric code, that is NFPA 70. So we'll just try to find NFPA 70. As you see, there are many other codes in here as well that you can use. So I think so we will go one page back. If you scroll down over here, you will have NFPA 70 National Electric Code over here. Once you click on that National Electrical Code, NFPA 70, when you scroll down over here, you will have the option of free access. So similar to ASHRAE read-only resources, we have free access for the NFPA as well. Just the thing that you need to create a free account on their website. So make sure you create a free account. Once you go to the free access, it will look something like this for you. All right. So this is the, let me go to the very first. I'll click on free access. And one more point to note is that you can even check the historical code that have been in place. So the National Electric Code, the first version came in 1897, and all through the years that the National Electric Code went on improving, you'll have those copies over here. So now going back to the option, when I click view free access, it brought me to this particular page. Now what I want to do over here, I want to find out the table that is required for a given conductors. All right, so we have the wires, which technically are called the conductors because it conducts electricity, and then you have the conduits, the basically the pipes through which the conductors are passed so that the power can be facilitated through the conductors. So in the NFPA 70 National Electric Code, you have different chapters. Just like we had sections in ASHRAE 170, you have the chapters over here. Chapter number 3 is regarding the wiring methods and materials. And over here, you'll get section 310 conductor for general wiring. All right. Once you click on that, it will take you to the particular section. Again, since this is a free version, you get only viewing rights. You won't be able to copy and paste everything. But I'll also show you from other resource on the internet, how do we find it. So over here, what we need to do is we need to check the table that is required for the given insulated conductors with not more than 3 current carrying conductors in a raceway, cable or earth. All right. So this is the table 310.16 under the article 310 of NFPA 70 National Electric Code that we will have. All right. Now over here in the table, as you see, we have 2 sections over here. We have the section on this side for copper that contains the first the 3 columns on the left hand side over here, and then we have aluminum or copper clad aluminum conductor. All right, and again we have 3 given columns over here. Now this becomes a conversation on budget because copper tends to be expensive as compared to aluminum or copper clad aluminum. So always make sure you have a good conversation with the client regarding the costing of the given runs of the given conductors, and then make an informed decisions. Can we go with a copper or can we go with an aluminum? All right. The procedure that I will tell you right now will be the same. Either you use copper or aluminum. But yes, this conversation, try to have it with the client as soon as possible so that later on you will not need to do the recalculations again. Right. So now, since I understand that not everyone might have access to this particular PDF right away, what I want you to do is search for NEC conductor chart on Google. NEC conductor chart. So once you do that, I want you to go on this website on the media.distributordata-solutions.com. It is a PDF. It is the same table that you have in the NEC that we are looking over here, that you can use right now to refer and follow me. If not, you're not able to access for some reason either of the resource, just pay attention to how we are doing the calculation over here. All right. So now what we need to do is we need to, first of all, as I mentioned, we need to make sure that we identify the material of the conductor correctly. Then once we have identified the material of the conductor currently, we will assume for our exercise that it is copper. Now this copper has again 3 columns over here. All right. We have a column for 60 degrees centigrade, one for 75 degrees centigrade, and one for 90 degrees centigrade. Industry standard is for using 90 degrees centigrade so that if the wire does heat up, it does not become brittle over the time and then gives rise to any problem related to fire or anything else. Okay, so there is one question from Karamira asking how can we get free access to NFPA standards. So just to let you know, it is as simple as just creating an account. So what we need to do is go to nfpa.org. Then in here, make sure you create an account. Once you create the account, again, it is a free account that you don't need to pay anything for the account. And then once you go on to the path that I've shown, go to for professionals, list and codes. The list and codes, select the NFPA 70 or any other. If you are working, let's say on fire alarm, NFPA 72 will be applicable. So if you want to go to 72, you can go to 72. And in here, when you scroll down, when you come to NFPA 70 or whatever code that you want to use, this page, scroll down over here. In this particular section, this is the top section over here. In this section over here on the NFPA 70 or any other code that you want to see, simply go ahead and select the type of the version of code that you require. In this case, we are relying on the 2023 National Electric Code because that is the latest one. They update it, I think so, every 3rd year or 4th year. And then simply click on free access, view free access. That will take you directly to the free access version over here. Hope that answers your question. All right. So now I understand that creating the account might take some time. So that is why I asked you to simply search for NEC conductor chart. And in the conductor chart, you will find the same 130.16 allowable ampacity for insulated conductors. So once you click on this, you'll come on this particular sheet over here. All right. So basically, we are talking about copper over here as our material that we have selected, and we are going with the 90 degrees centigrade rating for this conductor. Now over here, as you see, there are a lot many numbers. These numbers are basically the allowable ampacity for this particular wire size. And what is the wire size over here? I go all the way to the left or to the right and see the size over here. So this column and this column are the same. So over here, basically the 40 amperes can be gone through the 10 American wire gauge. The AWG stands for American wire gauge. All right. So 10 AWG can handle up to 40 amperes. All right. Now in our given example that we had for our project, the wires coming to this panel board, which is a 100 ampere panel board, let's say it is a 3-phase panel board. Excuse me. It is a 3-phase panel board. So we would require a minimum of 3 wires that are rated for a minimum of 100 amperes, right? So in this case, if you see, if you're trying to use a copper wire over here, then we will come to this number over here. We cannot go 95 because it is lower than 100 amperes. It can only handle up to 95 amperes. We need to raise it up to the next possible option that we have. So that is 110 or 110 amperes. Now 110 amperes, if you check to the left over here, that corresponds with a 3 American wire gauge. Now 3 American wire gauge is just for one phase. Now for 3 phases, we would require 3 sets of, or 3 numbers, 3 quantity of 3 American gauge wire. All right. So now we have 3 phases, and then we have 3 numbers of 3 American gauge wire, and in addition to that we will require one more that will be for neutral. All right, so in total we will have 4 wires serving this particular panel board that we are talking about here, that is of 100 amperes. All right, now we will go back to our whiteboard. Let me share my whiteboard with you. Okay, so I'm sharing the same whiteboard with you. Now let's say this particular, can someone give me an confirmation? Can someone give me confirmation that you can see my screen over here?
Yes.
Awesome. So in case, let's say this is our 100 ampere panel board. So this particular will be rated for 100 amperes. This is the wire coming out from the switchboard over here, which will be rated for 100 amperes. Basically, we are trying to have, let me draw the leader the other way. We will have 3 quantity of 3 American wire gauge for our phases. We'll have 1 number of 3 American wire gauge for our neutral. All right, so in total we require 4 numbers of 3 American wire gauge to be contained in this particular conduit. Now we are talking about conduit. So those wires will need to be drawn through the conduit. So we would require a conduit that is big enough. The hole of that conduit, the bore of the conduit is big enough to handle the thickness of these 4 number of 3 American wire gauge. All right. Now let me share my desktop again with you. Emmanuel, you might want to hide video for everyone. Okay, so okay. Okay, now going back to that same table. Now over here, as you see, the American wire gauges keep on changing on this column as we go from row to row. So an 18 American wire gauge will only be able to handle 14 amperes. Similarly, a 16 American wire gauge will be able to handle 18 amperes. Now we have deduced that 3 American wire gauge will have 110 amperes that it can handle. Now, as you see, the amperes also increase, and so does the sizes. They change as per the ampere increase. So what is happening over here, as you go from top to bottom, the cross section area of that particular wire size, the conductor size, is increasing. All right, so if you cut the conductor and try to have comparison between the 4 American wire gauge and 3 American wire gauge, the 4 will be smaller as compared to the 3. Okay, I know it is a bit confusing, but because the numbers seem to be reducing, the American wire gauge seems to be reducing, but 4 American wire gauge will have a smaller cross section area as compared to the 3 American wire gauge. Now if you're trying to have the 3 American wire gauge, 3 or 4 wires of 3 American wire gauge going through one conduit, we need to have the conduit sized properly, right? So in this case, when we were talking about the wire gauge for the wires going from the switchboard to the panel board, they as I mentioned were underground. All right. So when you have an underground wire system that is going on, you'll need to make sure that you have good proper protection given to that conductor. So basically trying to say that the conduit should be rated for that kind of use, right? Versus what you might, let's say, have in your room, right? In your room, not necessary that you need to have the same rating for your conduit as compared to the underground conduit. Underground conduit will have moisture, might also have the loads that might go over it, so on and so forth. So the underground conduit usually tend to be more rigid, more able to absorb the stress strain of the earth as well as the loads. Along with that, trying to be as water resistance and water emit, not able to have the water go into the conduit. That is what I'm trying to say. So for that case, similar to this particular table that we have, now that we have deduced that we need 4 quantities of 3 American wire gauge for the 100 ampere panel, what we need to do is we need to select the conduits that are required for housing these 4 wires. All right. For that, just like we had the NEC conductor chart, I want you to type of NEC conduit chart. All right. So again, this is again going back to the National Electric Code. In here, you will have this first option of electrical estimating 101.com. Again, it is a PDF. It will open this particular PDF. So this particular PDF will again give us these American wire gauges on top over here. So if you remember properly, we have a 3 American wire gauge based on the 100 amperes that we are talking about over here. 3 American wire gauge in this second row over there is our given size for the conductor. Now, if you come down one by one, you'll see 1, then you'll see 2, and then you'll see some more sections divided as per the row, right? The first one section is for a half inch, 3/4 inch, 1 inch, 1 1/4 inch, 1 1/2 inch, so on and so forth. So the table is quite big. So if you have a bigger projects going on, you can also have these kind of given conduit sizing. All right. But for our project, what we are going to see is for the 3 American wire gauge, we need to fit a total of 4 quantity of wire. All right. So if you come down this way, you will have different types of wires that you can see over here. All right. So that is then divided into EMT, RMC, IMC, 40, 80, FMC, LT, so on and so forth. All right. So this basically is different types of conduits that are available in the market. Now, the type of availability might depend on geography to geography, but most probably you will come across the EMT, that is the electrical metal conduit. Then you will have the 40, which is the Schedule 40 PVC, 80, which is the Schedule 80 PVC, flexible metal conduit. Now, when you have any underground given project, all right, so any underground part of the given project, try to use Schedule 80 PVC. The reason I'm saying this, preferring 80 Schedule PVC over Schedule 40 PVC, Schedule 40 PVC do not have the ability to handle a lot of stress if you are putting it underground. And again, as you see, if you have the transformer sitting at your property line, and then you have underground conduits that contain the conductor coming back to your switchboard, you might have, let's say, walkway in between, you might have parking lots in between, so on and so forth. In that case, you need to assure that the given scenario does not break your conduit, essentially exposing the conductors in it. All right. So in that case, what we are going to try to check is which Schedule 80 PVC can handle up to 4 quantity of number 3 American wire gauge. So if we are going down over here, we see the IMC can handle 4, but we are looking for a schedule 80 to handle 4. So we'll go down again, and you see the schedule 80, which is 1 1/4, can handle up to a total of 5. A total of 5 number 3 conductors. Now, if it can handle 5, it can properly be accommodating for 5. It will accommodate even 4. Essentially saying it might be a big. The conduit, the size might be a big for the given 4 conductors that we are talking about. But that is fine. As long as we are not undersized, it is fine. You can go to the next possible option over here. All right. So now what is going on is on the, let me share my whiteboard again. Now I'm sharing my whiteboard again. Can someone give me a confirmation that you can see my whiteboard? Okay, I'll take that as a yes for now. But what we are trying to say over here now is this particular conductor set that is coming in will need to be in the minimum 1 1/4 inch, quarter inch conduit. All right. So now this is the cable management that will happen for all of the spaces. All right. Now what happens is when you check for these bigger ampere sizes, it is fine that you note down each and every one. All right. But when we are talking about, let's say, the outlet, right? The other day we spoke about the receptacles being 16 amperes as a standard in Rwanda. So for a 16 amperes, you don't need to mention each and every wire size, each and every conduit size, because that outlet is going to have 2 or 3 wires, one for phase, one for neutral, and one for ground. But phase and neutral is what we are talking about over here. So basically trying to have a standardized American wire gauge sizes for the given 16 amps. So what note you can put on your drawings is that the given conductor size needs to be a minimum, let's say 12 American wire gauge, in case it is not noted on the given particular plan or riser diagram. All right, everyone with me till now? I can get a yes, no, something. All right, I'll take that as a yes. But this is where we will transition into Revit for the given riser diagram, because this was the given cable management that we are talking about. Let's move on to the riser diagram in Revit. If anyone has any questions, please drop it in the chat box and we'll go forward with it. But for now, let me share my screen for Revit with you. All right, so everyone with me till now. So what we are going to do is we are going to create something called as a drafting view. All right. So for creating a drafting view, similarly how we had created the floor plan, reflected ceiling plan, we'll go to the view ribbon, and in the view ribbon, what we will have is the drafting view on top over here. All right. So view ribbon, drafting view. All right. So now it will ask me what is the scale of the drafting view. Last week we had discussed regarding the scale, how to shrink the scale, how to make the scale bigger so that you have the entire sheet fit. In this case, it is fine if you go with the 1 inch equals to 1 foot, or in case you need to have some kind of custom scale, that is fine as well. As long as all of the information that we want to show fits on the given drafting view, we are fine with it. All right. So over here, I've selected 1 inch equals to 1 foot, and the name of the drafting view, we can put it as the electrical electrical single line diagram. So many a times it is also called as one line diagrams. Sometimes it is also called as electrical schematics. The same thing that we are talking about. Since we will not be able to show each and every conduit on the floor plan, what we are going to do is we are going to give them a good idea of how to draw the power from the transformer to the switchboard to the given given panel board. All right, so now with the view ribbon, we have created the drafting view with this option at my cursor. It gave me this particular window, new drafting view. We have selected the scale as 1 inch equals to 1 foot 0 inch, and we have named it for electrical single line diagram. When you hit OK, this is your blank drafting view that has opened. Now what we are going to do is we are going to draw detail lines for the electrical drafting view. All right, so again, going to annotate, you have the detail line, annotate ribbon, you have the detail lines over here. Once you click it, you will have the detail line cursor activated, and you can simply start drawing it. Does anyone have any question? I heard some feedback. All right, if not, then we'll go back to the drafting view. Over here, just like the first day when we were not able to identify the rooms, we had added a text symbolizing the room number. What, Grace? Not yet. Sorry, Grace, I didn't understand your question. If you can type it again. Okay, so what this first line we are trying to do is we are trying to show the ground floor. All right, so making sure that the contractor properly understand what we are talking about, we will make sure we have ground floor typed out, and then we will put it on the line over here. Okay, now since our project had 2 floors, right, the ground floor and the level 1, or level 1 and level 2, if you are in a different geography, sometimes the ground floor gets called level 1 as well. So whatever be the case, make sure you follow the instructions given by the architect, because architects will be the ones who will be naming the floor plan, will be naming the room, will be tagging the for numbering the rooms as well, so on and so forth. All right, now taking these two, all right, the line, the detail line that we have drawn, and the text that we have added over here, let's copy it. All right, select both of them, either simply select it with your tooltip, or click on one and then click on the second one to select both of them. When you have in bracket 2 over here, basically that means you have selected 2 items, but since it is multiple categories, it will show multiple categories selected. Again, going back to the modify ribbon on the top over here, you will click on copy, and then you can select, just like we had used the rotate command, we will have a reference point. You can click one reference point and you can try to have it duplicated. Please note, the single line diagrams are not to scale. All right, although we have added 1 inch equals to 1 foot 0 inch, these will not be to the scale. The floor plans are to the scale. All right, so when the contractor is building something, they will have a scale, a foot ruler with them, and then they will measure how much area or how much distance that needs to be covered on the given printout, the hard copy printout that we are talking about, and then it will take care of then they will take care of the construction. Now with the ground floor assigned, we'll also have the first floor that we will add over here. Right, so this is the ground floor and first floor that we are talking about. So this is just signifying that anything that we have on this line or between the first floor and ground floor will be included on the ground floor. Anything above the first floor will be on the first floor. If you have any equipment on the roof, you can again copy and paste the same levels and make a roof plan over roof level over here. Right, so now we have the first floor, we have the ground floor, and then we have the roof. All right, similar to what we had drawn on the whiteboard, now we will have on the ground floor, let's make it a bit bigger. we will have the transformer. For the transformer, again, we are going to draw a detail line. All right. And then let's draw it as a given square or rectangle. So if you don't have any standard setup in your company, I would strongly recommend that you type it out so that there is no given confusion between you and the contractor about what needs to be done and what not. So in this case, we'll call this particular transformer as transformer XA, and then let's give it a leader as well. The leader on top over here. All right. So now this is the transformer XA that will be powering our given project. All right. Now after this, we will start drawing the conduit. So going back to the whiteboard, just making sure that you follow what we are trying to do over here. I will show the whiteboard. All right, in the whiteboard, as I mentioned to you, we have the transformer, we have the switchboard, we have the panels, and let's say the inverter or the UPS that we are talking about. And these are basically the given levels, that ground floor, the first floor that we are talking about. All right. So now we'll go back to our single line diagram, and then we will start drawing the detail lines. So this is much more like just drawing lines in Revit as well, in AutoCAD as well. So we can start drawing this. We will make sure if the equipment is in the building or out of the building, we try to signify it with a line, like transformer will be outside, and then you have a line signifying that the interiors of the building start from here. Now we'll go ahead and draw another line that will signify the line going into the switchboard. Now let's say this is the switchboard. Just like transformer, make sure you tag it properly. You can simply copy and paste the same text, or you can use another one. Always try to make sure that you don't have any of the elements like this overlapped with any other elements. It just gives a bad impression when you are trying to present it to the client. So let's say this is the switchboard. Then this switchboard, we will go ahead and draw it connected to, let's say, the panel board. Panel board or distribution panel, whatever the correct lingo is in the market. All right. Now, if there is another one that gives access to the UPS, we can go ahead and show that as well. So it comes to the UPS. Let's say this is our UPS, and then it will power the given panel board that we are talking about over here. All right. Now we can get it connected from this UPS to the panel board. Again, right now, if I try to identify this,
your whiteboard.
Oops. Okay. So sorry. So sorry about that. Okay. I will go back over here. So everyone was with me till the transformer, right? Because transformer was before I did that. So this is where we were. So we are talking about transformer over here. What I was mentioning was, if you have a distinction of interior and exterior, because transformers are usually mounted on the exterior, make sure you properly identify that with maybe a horizontal line. Again, this is a schematic, this is not a floor plan. So making sure that the client identifies, or the given contractor identifies properly, it will be what we'll be pushing for. All right. So again, this line will symbolize it is outside or inside. So if you want to add text over here as well, indoors, outdoors, that is fine as well, as long as you have that properly coordinated with the contractor. So now this is the transformer. We'll draw the conduits to the transformer. that come in from the utility. So this particular line will come from the utility. Right. After that, we will have the line going into the building. We will have it going into the switchboard over here. Right. And then we will have the switchboard that would be feeding the individual panel boards in the given rooms. Right, so this is, let's say, the utility panel board that we had for the surgical room, for the operating room, and then we will have another line, let's say, going for the UPS. So it will go to the UPS first, it will feed the UPS. And then we can simply copy this 4 lines. Again, these are just annotation elements, so you can simply copy it. There is no data that is associated with this that will be affecting our floor plans. And then this is feeding the other manual. Is it possible to do 3D conduit routing, connecting lights, switches, receptacles to power? Yes. So there is a question from Tony. Is it possible to do 3D conduit routing, connecting lights, switches, receptacles to power distribution boards in Revit coordination with other system? Is there any standard for cable tray sizing? So let's talk about the single line diagram before we move on to that, because this one I want to make sure that you understand regarding the sizing. So now talking about this one is our switchboard. All right. If you have a unique names, if you have multiple switchboards, make sure you properly name it out. Now, since this particular panel that we had, let's check the name of that panel board. So this particular panel, we had named it for OR1 UTI. So we'll go back to the single line diagram. So this will be our OR1 UTI, basically the utility panel serving the given operating room. And then this one is the OR UPS panel, if I remember it right, because this one is being powered from the given UPS. And this one is the UPS that we had sized, right? The other day we had spoken about the diversities regarding 500 watts maximum per outlet or receptacle. So we had sized our UPS accordingly for the operating room. Now over here, both of these panel boards, we have selected it for 100 amperes. So the wires coming out from the switchboard, it needs to be 100 amperes. All right. Rated for 100 amperes. We have saw that there are 4 numbers of number 3 wire gauge that we will use in a given conduit, that is minimum 1 1/4. So we will again note this. I've taken the same annotation tag over here, the text over here, and copied it and pasted it on this wire over here. And over here we will try to have a description saying 4 number of 3 American wire gauge in, let's say, 1 1/4 inch conduit. All right. So now over here, as you have seen that I've made quite a few abbreviations. All right. Make sure that you always include these abbreviations on your first cover sheet that you have. All right. Now, similarly, what we need to do is we need to tag this wire as well. But if you notice, both of these panels are similar, except for this one will be connected to the UPS and this one is directly connected to the switchboard. So both of them are 100 amperes, but we need to make sure that both of their conduits are properly tagged. So you can use the same tag since this particular wire and the conduit size will be similar to what you're using for this one. So what we can do is either add another tag to this, or you can create one more text block itself. All right, add another leader to this, or you can create one more text block. So since we have added one more tag, make sure we are pointing it over there. Now, when the contractor orders all of these stuff, what he is going to do is he will compare your line diagram or the schematic with your floor plan. Now in your floor plan, if this particular one is tagged for OR UTI, contractor will check this OR1 UTI and then try to find it over here. Now over here, he will get the information that this is OR UTI. It is connected to the switchboard. It will have 4 numbers of 3 American wire gauge, and it will be 1 1/4 inch conduit. All right. So what he will do is he will check the location of the given transformer. You will check the site conditions, because many a times what happens is the underground conditions are not known during the design phase. He will check on field what is going on, maybe dig a trench and see if there are any existing utilities that might need to be routed, so on and so forth. And then based on this 2 information regarding the location on the floor plan and what we have seen over here, he will usually send us the shop drawings for approval. Once we approve it, only then they will start giving the ordering. All right. So now this was regarding the single line diagram. Now the same thing, if you have 20 more given panel boards, you simply have to make sure that you have them shown properly. So over here, if you have 20 and let's say all of them are powered through the switchboard, make sure you have the proper lining shown to the given panel boards. All right, make sure you have the proper callouts and the tags assigned so that they correspond with the tags on the floor plan as well. All right, so that was regarding the single line diagram. Any questions till now before I move on to the 3D conduit routing connecting lights, switches and receptacle to power distribution boards? Okay. All right, so I have not seen any questions or points from anyone, so I'll move forward regarding the conduit routing. Now, as we saw last week, we have 2 sets of given floor plans that we are working with. We have the lighting floor plan, and then we have the power floor plan, right? So lighting is where we have shown all of the light fixtures, and technically power should be only showing up as the power. If you are seeing both, if you are seeing power and lighting on the same thing, go to the visibility graphics, just type in VV for Victor, and make sure you turn off the light fixtures, because we don't want light fixtures only on the lighting plan and not on the power plan. Right. So next thing is regarding, okay, so point from Tavalcalt, does this mean that the schematic is not generated automatically? The answer is no. If you don't have any add-in and if you are just working with Revit, it will be the manual schematic that you need to do. It does not get directly automated, just like we had automated the given panel board schedule. There is no way without an extra add-in, a purchased add-in, that you can do that, right? Now next point regarding the conduit routing. Again, this is something that the contractor will usually do as a part of LOD 400 for fabrication. On the part of designing, when we are talking about consultancy, usually they have it as a specification, just like I told you regarding the wire sizing, right? So if the wire size is not noted on the single line diagram, then they need to use one of the wire types that you have noted somewhere in your specification, right? But just to make sure that everyone understand, So Grace is asking, can we copy an existing AutoCAD schematic and paste it onto Revit? Yes, surely you can do that, Grace. But I would strongly suggest get everything in AutoCAD so that your coordination is done properly. Plus, if you are bringing in AutoCAD, I'll show you how to link AutoCAD in a moment. But if you are bringing in AutoCAD, make sure you properly explode all of the blocks from AutoCAD before bringing it into Revit. Just because the interface of Revit and AutoCAD did not sync one-to-one, and then there might be some blown out things that you might be seeing on the Revit drafting plan. All right. I will come back to the AutoCAD schematics in a moment, Grace. Give me a moment. So now going back to the conduit routing. To answer Tony's question, Tony, this is something similar to the piping layout that we did the other day. Okay, we have the systems, right? And then we have the given electrical, and then we have the conduits that we can have over here. All right. So now you can start drawing the conduits. Just make sure that you have it properly coordinated with the 3D view, something similar to the piping that we were doing the other day. So for example, let's say we will draw some conduits from the given outlets to the panel board. So again, I'm drawing a section. Repeating myself over here, team, that always make sure that you are at least working with two sections when you're two views, one floor plan and maybe the other one section view or a 3D plan view, so that we can understand if any conflict is happening in our floor plan. All right. So this view activated, I will go over here, and over here we can start drawing the conduit from this particular outlet. So you can go up, you can get it coordinated, and then properly make sure that it comes back to the panel board. So this is what will help you when you are trying to have conduits modeled regarding given the coordination aspect. So going back, draw conduit, and we go back over here. All right. So oops, what is going on? So this will give you an idea regarding the conduits that need to be drawn on the floor plans. And again, as I said, we need to have at least 2-3 sections. Over here, as you see, this conduit technically cannot go down. It needs to come back to one of the given panel boards on this side and then drop down. But again, looks like the view range got cut off. So we'll go back into the view and try to identify the conduit over here. Just confirming over here, and then conduit. And this is the conduit that we are drawing over here. But again, talking about coordination, this is something that the electrical contractor will be taking care of. So this conduit size will also go back to our given conduit size over here. If you are using a 12 American wire gauge, because we are not going to go each and every receptacle to be of a different kind of size, right? We need a standardized size of 12 American wire gauge if you decide that is your given size. And since it is interior, you can also have the 1/2 inch that will be going through it. So 1/2 inch for 40 scheduled PVC, since it's interior, you can go a maximum of 5 wires. So that will include your phase and neutral, and if required, the given ground as well. So that is how you will do it, similar to again what we are talking about piping that we had seen on Friday. But that is how you can get the conduiting route it. Again, make sure that you at least work with 2 or 3 views simultaneously so that your coordination is done properly. As you saw that I had drawn the conduit based on this particular section, and then it just created the conduit length up till here, which was not correct. We wanted the conduit to go all the way up till this point, right? So that is how we can get the conduiting done. Next was regarding the AutoCAD. Okay, so Grace, for AutoCAD, again, as I'm mentioning, try to have the single line diagram done in Revit as much as possible. But in case there are some company standards that you need to follow, again, create a single line diagram, go to the insert ribbon. Earlier, when we had begun the course, we had used link Revit. Instead of link Revit, we can use link CAD over here. In the link CAD, it is similar. You select the CAD file over here. Again, make sure you have the CAD file that you're trying to bring in properly bursted or exploded, so that you don't have any blocks that come into Revit, the AutoCAD blocks that come into Revit. That will basically create issues when you're trying to bring your CAD into Revit. It will show a bit of offsetting that will basically not work out well if you're trying to show it on your floor plan. But again, just select the particular given DWG file. You can either keep your colors as is, or you can change it to black and white. Levels, layers, you can keep it all. Import units, you can still keep it all. Sometimes if you have site plans, civil plans, which are at slightly off axis, if you have this turned on, it creates issue. So I would recommend keeping this correct lines that are slightly off unchecked. Positioning, again, this positioning is similar, I would say, to what we had discussed when we were linking the Revit model. But this will come into picture if you are linking a 3D civil model onto your floor plan or drafting view. So over here, auto positioning is fine. From origin to internal origin is fine. You simply need to click on it, hit open, and that CAD AutoCAD.dwg schematic will be in your drafting view, which you can simply drag and drop it onto your onto your sheet view. So hope that answers your question, Grace. Any other questions? Because those were all the questions that I could see over here from Friday as well. Because we are coming to a conclusion over here, please type in the questions, any other questions that you might have. Okay, if that is a no, then what I'm going to do is I will type down my email address over here. Since I had given my cards to the folks that attended the event in person, but in case online folks have any questions, please feel free to drop me an email. I'll try to make sure that I get back to you as soon as possible. But if not, if we don't have any questions, then I'll hand it over to Emmanuel.
So thank you, Mr. Tejesh. Have you ever tried to answer the questions asked by those guys online, Grace and someone called Popora?
Yes. Popora, I've answered it. Tony as well, I've answered it. Grace, I had answered it, but she has followed from her point. She is saying, however, you explained that we can link CAD schematics, but not copy and paste in CAD. Grace, please explain me. Copy and paste in Revit. Okay. No, Grace, you will need to link it. You cannot directly copy it like a copy base 0,0 and paste it on the drafting view. You will need to link it. So in case you need to change the single line diagram in the future, you'll need to change it on the CAD file and then come back to this link and then go to manage links over here and in the managed links, you will have another CAD file that you will see over here. Just like we had reload this one to show up the room numbers, we will reload that CAD file that you have saved at a central location, and that will save it, that will update the schematic basically over here. That is what I'm saying, like that extra step sometimes gets lost in translation. So I would strongly recommend that you use Revit for even your schematic, and even for multi-million square foot projects, we are using schematics done in on the drafting view. So so that is what I would suggest to you, Grace.
Okay, thank you, Mr. Tejesh. Thank you for your time, and I hope this is the end of our MEP expert seminar. Yes, Tejesh, or not?
That is correct. That is correct. That is correct. And again, if anyone has any questions, please feel free to get in touch.
So, engineers, I want to take this time.
I have one more question.
Sure.
I don't know if you can hear me.
Question from Lawrence.
Okay, from Grace. Can I share my screen?
Sure. Yeah, please go ahead.
Okay, no problem.
Wait. Yeah, okay, all right. Yeah.
Okay.
Yeah, Tejesh, while Grace is trying to share our screen, can I quickly ask this question? You gave us some link for ASHRAE read-only, ASHRAE Meteo, International Plumbing Code, NFPA.org. Is there any one we have for medical gas piping?
Medical gas, yes. You can go to just a minute. There is one from the UK Association. Let me send it over to you. I will send it to Lawrence. I'll send it to Emmanuel Lawrence, and then he will share the med gas piping sizing with you. All right?
Yes.
All right. Yes, Grace, I can see your screen now.
Okay, so I have a question. So in a case where you have your socket outlets or receptacles, as you've been calling it, placed this way on the floor plan.
Yep.
But then when you go to the section, instead of the two sockets aligning with each other, in section it has space in between. Sorry, let me open the particular section.
Sure.
Okay, so you have this. How do you solve it? And you know that when you bring these two together on section, the socket outlets on the layouts or on the view, they are going to be kind of overlapping.
It is. So go back to the floor plan, Grace.
Okay.
So over here, Grace, what you're seeing is an annotation element. It's a symbol. It is not a 3D view of the or the actual view of that given particular outlet. Okay. So now I see that your scale is set to 1:100, right? On the lower left hand side. So click on that and let's try to change it to some other scale. For instance, any other.
So 1:50.
Let's take that. All right. Now you see the symbols back over there.
Yes.
That started to come close and close, right?
Yes.
All right. So now you can bring it close, but yes, you will need to change your scale over there. All right. As you go from 1:100 is from 1:1. Basically, 1:1 is your exact specific dimension. Right?
Okay.
And then once you start increasing your scale, your symbols will also start increasing. But what that will do is it will change everywhere. Does that make sense, Grace?
Yes, it does.
So either you can do one thing, either you can change your scale for this floor plan, but I understand changing the scale, what it means, or else what you can do is you can, whoever your BIM manager, if there is one in your project, you can ask them to change the symbols to make it smaller. Right now, the symbols are a bit bigger in the given family of Revit.
Okay. All right. Thank you.
Awesome. Yep. Any other questions from anyone else?
Yes, back to the medical gas link.
So give me some time, Lawrence. I will send you the link. I'll send it through Emmanuel, the link, how to size it.
All right, thank you.
Yeah. Any other points or questions from anyone?
No other question? No other question before we go to the end? The engineers from Rwanda. Anyone with a question? So, engineers, we are seeing that there is no more questions to be answered by Mr. Tejesh before we leave the training room. So, once again, I want to take this time to thank everyone who have attended and participated in this MEP expert seminar. Your active participation and enthusiasm contributed greatly to its success.